Hello everyone, today is discuss about BSc first year. Paper name is mechanics, that is semester 1 paper. So today is discuss about gravitational field and gravitational potentials and Kepler's law of planetary motions, that is 3 laws. Kepler's first law, second law and 3 laws is derived that in these equations. So what is a gravitational field and gravitational pole? Let us consider one is a big mass and another one is a small mass. This is attractive both of these forces, and that is the distance of two masses is r. So let us consider this is a big mass is earth and another one attracting, that is earth is a big sphere of this heavy mass and the earth attractive and other body of the ranges, that is the range covered under the attraction of these forces, that is called the gravitational field. And Newton's gravitation law, one example is pen and hand is both are attractive, that is the gravitational force. Let us consider two masses, that is one is the earth mass is capital M and small is another body is the mass is small m, and two masses are, that is earth and other body is attracting to both are them, that is the gravitational field. Newton's law of gravitational states that the gravitational force between two masses, that is m and small m and capital M, that is the distance of r, that is force is proportional to the small m into capital M and inversely proportional to the distance of two masses is r. So that is force is inversely proportional to the square root of the distance. So that is F proportional to 1 by r square. So total that is two masses is proportional and inversely proportional to the square root of the radius, that is F proportional to m by r square, capital M and small m by r square, that is F is equal to g mm by r square. G is the constant, that is gravitational constant. So that is gravitational force. Gravitational force is the SI units of this constant of the proportional of g, that is F is equal to g into capital M small m by r square, that is the g is the gravitational force or gravitational constant, that is the value of 6.67 into 10 to the power of minus 11 Newton meter square per kilogram square. So that is F is equal to minus g mm by r square. Here the negative sign is attractive of this force. So two masses is attractive, that is the opposite direction. So that's why minus is indicating this is the gravitational force. And gravitational potential. Gravitational potential is the amount of work done is to a displacement a body from definite distance to a resistance by opposing the force. That is gravitational potential V is equal to minus gm by r, that is that r means that is the distance, that is negative sign is the attractive of this indicating symbol. Gravitational potential units is the Newton meters per kg. So V is the gravitational potential due to the gravity and m is the mass of this source and r is the distance of this between sources and unit masses, that is the gravitational potential. So these are two formulas using in Kepler's laws, gravitational potential and gravitational field. These are both are applying this Kepler's laws in derive the equations. Next, Kepler's laws. Kepler's laws of a planetary motion. He is the Kepler's scientist. Johann Kepler was a German mathematician and astronomer who discovered the earth and planet traveled about the sun in an elliptical orbit. He gave three fundamental laws of this planetary motions. సో కెప్లర్ సైంటిస్ట్ తర్వాత న్యూటన్స్ వచ్చారు, తర్వాత మనకి 400 years బిఫోరే కెప్లర్స్ సైంటిస్ట్ అనే అతను సన్ రొటేటింగ్ ఇన్ ఎలిప్టికల్ షేప్లో ప్లానెట్స్ అనేటివి రొటేట్ అవుతున్నాయి అనే దాన్ని ఎక్స్ప్లెయిన్ చేయడం జరిగింది. సో అతను దట్ ఈస్ 3 laws అనేటివి ఎక్స్ప్లెయిన్ చేయడం జరిగింది. ఫస్ట్ లా ఈజ్ ద లాస్ ఆఫ్ ఆర్బిట్స్ అండ్ సెకండ్ లా ఆఫ్ ఈక్వల్ ఏరియాస్ అండ్ లా ఆఫ్ పీరియడ్స్. కెప్లర్స్ ఫస్ట్ లా, this is the law of orbits. So Kepler's first law statement is all planets revolving around this sun in an elliptical orbits having the sun at one of the foci. ఒక సర్కిల్ తీసుకున్నప్పుడు దానికి సెంటర్ పాయింట్ మనకి ఐడెంటిఫై చేస్తాము, అదే విధంగా ఎలిప్స్ షేప్లో ఉన్న దానికి సెంటర్ పాయింట్స్ అనేటివి 2 ఉంటాయి, దట్ ఈస్ F1 అండ్ F2. దీస్ ఆర్ 2 ఆర్ ఫోకస్ F1 అండ్ F2. దిస్ ఈస్ ద ఎలిప్స్కి సెంటర్ పాయింట్లో మనకి సన్ ఎక్కడైనా ఉండొచ్చు, ఇది బోత్ ప్లేసెస్లో సన్ అనేది తీసుకోవడం జరుగుతుంది. సో సన్కి మనకి నియరెస్ట్లో ఇక్కడ లెటస్ కన్సిడర్ ఈ ప్లానెట్ అనేది ఎలిప్టికల్ రివాల్వింగ్ అరౌండ్ దిస్ సన్ సో ఎలిప్టికల్ ఆర్బిట్లో ఈ షేప్లో మనకి ప్లానెట్ అనేది రివాల్వ్ అవుతుంది. లెట్ us కన్సిడర్ ఎర్త్ ఈస్ హియర్ అండ్ హియర్. సన్కి నియరెస్ట్ పాయింట్లో ఉన్న వాటిని ఏమంటామంటే ఫెరీలియం అని చెప్పడం జరుగుతుంది. సన్కి లాంగెస్ట్ డిస్టెన్స్లో ఉన్న పాయింట్ని ఎఫీలియన్ అని చెప్పడం జరుగుతుంది. సో దిస్ ఈజ్ ఎఫీలియన్ అనేది మనము RAగా రిప్రజెంట్ చేయడం జరుగుతుంది. లాంగెస్ట్ డిస్టెన్స్లో ఉన్న పాయింట్ని. సన్కి నియరెస్ట్ పాయింట్లో ఉన్నదాన్ని మనం ఫెరీలియంగా తీసుకోవడం జరుగుతుంది. దట్ ఈస్ RPగా రిప్రజెంట్ చేయడం జరుగుతుంది. దిస్ ఈజ్ మైనర్ యాక్సెస్ అండ్ మేజర్ యాక్సెస్గా డిసైడ్ చేయడం జరుగుతుంది. దిస్ ఈజ్ ఎలిప్టికల్లో మనకి 2 సెంటర్ పాయింట్స్ ఉంటాయి. ఈ 2 సెంటర్లో సన్ అనేది ఎక్కడైనా ఉండొచ్చు. దీనికి సన్ చుట్టూ రివాల్వ్ అరౌండ్ దిస్ సన్ ఇన్ అన్ ఎలిప్టికల్ ఆర్బిట్స్. ప్లానెట్స్ అనేటివి ఎలిప్టికల్ ఆర్బిట్ షేప్లో రౌండ్ అవ్వడం జరుగుతుంది. సన్ అనేది ఎట్ వన్ ఆఫ్ ద ఫోసి. దిస్ ఈస్ ఇక్కడైనా తీసుకోవడం జరుగుతుంది ఫోసి. సన్ అనేది ఇక్కడైనా 2 ప్లేసెస్లో మనకి సర్కిల్కి 1 సెంటర్ ఎలా ఉంటుందో ఎలిప్టికల్కి కూడా 2 సెంటర్స్లో సన్ అనేది తీసుకోవడం జరుగుతుంది. ఏ ప్లేస్లో ఉన్నా దానికి నియరెస్ట్లో ఉన్న దాన్ని ఫెరీలియం అని అండ్ సన్కి లార్జెస్ట్ డిస్టెన్స్లో ఉన్న పాయింట్ని ఎఫీలియన్గా కన్సిడర్ చేసుకోవడం జరుగుతుంది. సో గ్రావిటేషనల్ ఫోర్స్ దట్ ఈస్ F ఈజ్ ఈక్వల్ -gmm/r² ఇంటూ r క్యాప్. ఇక్కడ హియర్ r క్యాప్ ఈజ్ ద యూనిట్ వెక్టర్. యు నో సెంట్రల్ ఫోర్సెస్ ఈక్వేషన్ అనేది ఇక్కడ అప్లికబుల్ చేసినట్లయితే దట్ ఈస్ F ఈజ్ ఈక్వల్ టు F(r) ఇంటూ r క్యాప్. సో హియర్ F ఈజ్ ఈక్వల్ -gmm/r² ఇంటూ r క్యాప్. సో what is the radial acceleration formula? d²r/dt² minus r into dθ/dt whole square. This is the radial acceleration formula. You know radial acceleration and another one is transverse acceleration. Both are equations is applicable in this equation. Okay. So transverse radial acceleration formula is the d²r/dt² minus r into dθ/dt whole square. So that is m into radial acceleration d²r/dt² minus r into dθ/dt whole square into r cap. This gravitational force and radial acceleration, these are both are equations here equal. So here -gmm/r² into r cap is equal to m into d²r/dt² minus r into dθ/dt whole square into r cap. So here r cap and mm is both are cancel. So -gm/r² is equal d²r/dt² minus r into dθ/dt whole square. That is equation 1. Let us consider r is equal to 1/nu. So this is the r equal to 1/nu, that is the derivation of with respect to theta. So differentiating of this r value. So dr/dθ is equal -1/nu² du/dθ. So here differentiating of 1/u is equal to -1/nu². So here nu with respect to theta du/dt. Here dr/dt is equal to, you can write dr/dt is equal to dr/dθ into dθ/dt. So these are dθ is cancelled, that is equal to dr/dt. So same equation he get dr/dt. Here dr/dt, then substitute in the above equation, that is -1/nu² du/dt into omega. Here dr/dt is equal to dr/dθ means -1/u² du/dt and dθ/dt. So dθ/dt is the omega. So here you can write the omega value -1/nu² du/dt into omega. -1/u² du/dt. Here what is r² into dθ/dt? That is the transverse acceleration. Transverse acceleration means 1/r d/dt of r² into dθ/dt is equal to constant value, that is equal to 0 అయినట్లయితే r² into dθ/dt is equal to p, that is the p is the constant value. Okay, that is radial acceleration formula, what? d²r/dθ² minus r into dθ/dt whole square. This is the radial acceleration formula. And again transverse acceleration formula 1/r d/dt into r² dθ/dt is equal to 0. So 1/r value that is equal to outside వెళ్ళినట్లయితే that is the constant value. Let us consider p. r² into dθ/dt is equal to p is equal to constant, that is the constant value. So you can substituting r² dθ/dt here, then you can write -1/nu² du/dθ. What is the w? W means dθ/dt. Here r² w means p/r². Here substitute the transverse acceleration formula p/r². So you can write 1 by nu means also r. So you can substituting 1 by nu square, that is r square. R square is cancelled, minus p into du by dt. Similarly, again differentiating with respect to t in dr by dt. So d square r by dt square by d by dt of minus p du by dt. So again differentiating with respect to t, you can write this equation minus p d by dt and du by dt and d theta by dt. So d theta dt is both are cancelled. This is the same equation, d by dt du by dt. You can write du by dt d theta by dt. D theta is cancelled, that is same equation. D theta by d theta is equal to omega. Omega means p by r square. 1 by r square is equal to nu square. So p into nu square. You can write this value in substituting in the above equation, minus p nu square d square nu by d theta square. Here d theta by dt means p square nu square and d square nu by d theta square. Then this is the d square r by d theta square. This equation substituting in this equation. So equation 1, d square r by d theta square minus r into d theta by dt. This is differentiating with respect to second term, and d theta by dt is substituting in the values in equation 1. So minus gmm nu square is equal to minus p square nu square d square u by d theta square. That is minus r into d theta by dt whole square. So you can write minus r means 1 by nu. So d theta by dt whole square means p square nu square. So you can write whole square, that is whole square kabatti p square into nu power of 4. Okay. So dividing with this equation p square and nu square and remaining in these terms. Okay, this is above equation dividing p square u square. So minus gm nu square by p square u square. So u cancel means gm by p square, and left side of this equation minus common and write RHS and LHS is equal to minus is cancelled, and d square u by dt square, that is dividing p square u square is 1, d square u by d theta square plus p square nu power of 4. Here also nu, then multiplying p square into nu cube and nu power of 4 cancel means that is nu. P square is cancelled. D square nu by d theta square plus nu is equal to gm by p square. You know, this is the second differential equation, d square x by dt square plus x is equal to 0, that is the second differential equation. So comparing this second differential equation form, and you can solution, you can write directly u is equal to 1 by r, and you can write u r 1 by r, that is equal to a cos theta plus gm by p square. This is the second differential equation form. You can write that the solution of nu is equal to a cos theta plus gm by p square. This is a is the constant, multiplying with p square by gm on both sides. This equation multiplying p square by gm. So multiplication and that is the value gm by p square means p square by gm is 1 plus p square a gm into cos theta is equal to p square by gm by r. You can write p square a by gm is equal to semi-lattice rectum, and p square by that is E is equal to p square a by gm, that is the value of eccentricity E. So you can write that is equation 1 plus E cos theta is equal to L by r. Here L is equal to p square by gm and small e equal to p square a by gm. E means eccentricity and L means semi-lattice rectum. That is the values is substituting, that is the equation simplify 1 plus E cos theta is equal to 1 by r. This is the Kepler's first law equation, and here in this equation you can write E let us greater than 1 value, then here planet is rotating in the revolving around the orbit in a hyperbola shape, and E equal to 1 value, simplification this equation, and E equal to 1, then orbit is the parabola shape, and E less than 1 is orbit is the elliptical shape. Okay. So here E less than 1 you consider orbit is the ellipse shape, and E equal to 1 orbit is parabola shape, and E greater than orbit is hyperbola shape. So this is L and E value can determine these 3 equations and 3 shapes. Okay, this is the L and E value determined of this shape of this path as equation. Here this is the derive this first Kepler's law equation. Okay, and Kepler's second law is the law of equal areas. This is the second Kepler's law. A line joining the any planet to sun sweeps out equal areas in equal interval of the time. That is, the area speed of the planet remains constant. Here second one in the మనకు 1 డేలో లేదా 1 మంత్లో this is elliptical planet is revolving around the sun is the one foci. సో ఈ sun ఇక్కడ ఉన్నప్పుడు మనకేంటి ఈ planet revolve అవుతున్నప్పుడు that is 1 month కానీ or 1 day. So that is example A to B is covered this 1 day in this area in planet, and another planet is revolving around C to D. These also 1 day is cover this area. These are both areas are equal. So that is the Kepler's second law. So equal areas, a line joining any planet, the sun sweeps in equal areas and equal interval of the time. That is called the law of equation of area. సో మనకి ఇక్కడ సన్ తీసుకున్నట్లయితే 1 డేలో ఎంత ఏరియాని కవర్ చేస్తుందో అదే ప్లానెట్ అనేది ఇంకొక డేలో కూడా మనకి అదే ఏరియాని కవర్ చేయడం జరుగుతుంది. దట్ ఈస్ ఈక్వల్ ఏరియాస్ ఇన్ ఈక్వల్ ఇంటర్వెల్ ఆఫ్ ది టైం. సో దట్ ఈస్ ద కెప్లర్స్ సెకండ్ లా. సో మనకి ప్లానెట్ అనేది సన్కి లాంగ్ డిస్టెన్స్లో ఉన్నట్లయితే దాన్ని మనం ఏమంటాం అంటే లాంగ్ డిస్టెన్స్లో ఉన్నప్పుడు మనకి గ్రావిటేషనల్ ఫోర్స్ కూడా తక్కువగా ఉంటుంది. సో డిస్టెన్స్లో ఉంటుంది కాబట్టి ప్లానెట్ యొక్క మోషన్ కూడా అది స్లోగానే ఉండడం జరుగుతుంది. ఒకవేళ సన్కి నియర్లో ప్లానెట్ ఉన్నప్పుడు దాని యొక్క వెలాసిటీ ఎక్కువగా ఉంటుంది కాబట్టి దాని యొక్క స్పీడ్ కూడా ఎక్కువగా ఉండడం జరుగుతుంది. సో ప్లానెట్ యొక్క మోషన్ కూడా ఎక్కువగానే ఉండడం జరుగుతుంది. దట్ ఈస్ ద సెకండ్ లా ఆఫ్ కెప్లర్స్ లా. Okay, this is the Kepler's law. So that is here A is the planet moves around the sun in A to B, that is the given time interval, and C to D is time interval, both are equal, and that is ASB and CSD equal areas. This is ABS and CSD, this is the areas is equal areas and equal with the same time interval. That is the law of equal areas. That is the derive this Kepler's second law. What is the formula? Area of the triangle is equal to half into base into height. That is half into that is base, that is r, and height అంటే A to B కి ట్రావెలింగ్ చేసినప్పుడు what is the value? R into d theta. So half into r into r d theta. And that is the distance of r. This is A to B travel చేసినప్పుడు angle of d theta. So what is the distance here? A to B, r into d theta. So that is the area of ABS, area of the triangular is equal to half into base into height. So that is base is r, height is the r into d theta. You can write here r square by 2 into d theta. D theta is the angle of time interval. So that is dA by dt is equal to r square by 2 into d theta by dt. dt is the angle turn in a time interval, that is d theta is multiplication on both sides, that is equal to r square by 2 d theta by dt means p. So you know that is transverse acceleration r square d theta by dt is equal to constant, that is p. So that's why this is, you can write p by h is equal to this value is the p is the constant. So that's why p by 2 is also constant value. Okay, this is the Kepler's second law. And so the equal areas and in equal interval of time అనేవి రెండు కూడా ఈక్వల్గా ఉంటున్నది. విత్ ఇన్ టైమ్ ఇంటర్వెల్లో ఎంత 1 డేలో కానీ 1 మంత్లో కానీ ఒక ప్లానెట్ అనేది ఎంత డిస్టెన్స్లో రొటేట్ అవుతుందో అదేవిధంగా మనకి ఇంకో 1 డేలో కూడా ప్లానెట్ అనేది అంతే డిస్టెన్స్లో ట్రావెలింగ్ అవ్వడం జరుగుతుంది. ఒకవేళ మనకి సన్కి నియరెస్ట్లో ప్లానెట్ తీసుకున్నట్లయితే దాని యొక్క మోషన్ అనేది ఎక్కువగా ఉంటుంది, వెలాసిటీ ఎక్కువగా ఉంటుంది కాబట్టి గ్రావిటేషనల్ ఫోర్స్ కూడా ఎక్కువగా ఉంటుంది. దాని ద్వారా దాని యొక్క మోషన్ కూడా ఫాస్ట్గా ఉంటుంది. అదే సన్కి లాంగెస్ట్ డిస్టెన్స్లో ప్లానెట్ ఉన్నట్లయితే దాని యొక్క గ్రావిటేషనల్ ఫోర్స్ అనేది తక్కువగా ఉంటుంది. సో దాని యొక్క మోషన్ కూడా లెస్గా ఉంటుంది. కాబట్టి దిస్ ఈస్ సేమ్ ఈక్వల్ ఏరియా ఆఫ్ ది టైమ్ ఇంటర్వెల్ ఈస్ ఈక్వల్ టు కాన్స్టెంట్, దట్ ఈస్ p/2 is equal to constant, that is the Kepler's second law. Okay, and next Kepler's third law. Kepler's third law is the square of the time period is proportional to the cube of the semi major axis, that is the Kepler's third law, that is law of period, that is t square is proportional to the a cube. Square root of the time period is proportional to the cube of the semi major axis. Okay, here this is the major axis, minor axis. Here this is the elliptical, this is the one of the forces sun, and this is a planet revolving around the sun. This is the major axis and this is the minor axis. So off part, this is the center point, this is the off, this is semi. Let us consider half of the part is A. A is the semi major axis and B is the semi minor axis. This axis is minor axis and this is the major axis. Totally this is the distance of 2a. So half of the part is distance is a, that is the semi major axis and semi minor axis. So you can prove that t square proportional to a cube, that is the Kepler's third law. T is the directly proportional to the square root of the time period is proportional to the cube of the semi major axis, that is here Kepler's third law. The relation between the semi latus rectum and semi major axis and semi minor axis. You know, semi major axis means A and semi minor axis means B. Here you can write equation L is equal to B square by A. You know that is semi latus rectum is formula, that is Kepler's first law derived that this semi latus rectum P square by GM. So that is equal to B square by A. So the time period is equal to area of ellipse by areal velocity. So that is area of ellipse is pi AB, that is AB is the semi major axis and semi minor axis. So that is pi AB by areal velocity. You know, here second law is equal interval of equal areal velocity. So that's why you can write areal velocity is constant p by 2. So here both sides squaring on both sides, t square is equal pi square a square b square by p square by 4, that is 4 is numerator and denominator is the p square. So taking t square is equal to 4 pi square a square and that is b square value is substituting in this equation, a p square by gm. So this is simplification, 4 pi square a cube by gm. So 4 pi square by gm is the constant value. So that's why t square proportional to a cube. So this is Kepler's third law is proved. So square root of the time period is proportional to the cube of the semi major axis, that is t square proportional to a cube. This is the Kepler's third law proof. Thank you.